Given a polynomial p of x equals x cubed plus 4x squared plus x minus 6, and c is equal to negative 3. So they give us this value c. They don't tell us what it is. They just give us this number. Find, is part A, is c a root or a 0 of the polynomial p of x? And part B, if it is a root, then find all the other roots. Okay, so they give us a potential root. We'll check to see if it is. And if it is, it shouldn't be too hard to find the others. Okay, so we have to synthetically divide. So we put our coefficients in descending order: 1, 4, 1, negative 6, and synthetically divide by negative 3, the c value they gave us. You notice we didn't put any zeros in there because there's no missing powers of x, but we always write them in there in descending order. Okay, bring down the 1, multiply by negative 3, we get negative 3. Add 4 plus negative 3 is 1. Multiply by negative 3, add, we get negative 2. Multiply, add, we get 0. We're having a party. Yes, yes, yes. We found that this c value that we tested, the one they gave us, c equals negative 3, is indeed a root, or otherwise called a 0 of the polynomial. Okay, so we're going to use that to find the other roots. And so we're going to use that c, but we're also going to use the bottom numbers on the bottom of the synthetic division that we just did to find the other factors. Now, since c is equal to negative 3, we know it's a root. So we can start our factorization by writing p of x as parenthesis x minus the root that we just verified, x minus a negative 3. And then we're going to multiply that by the polynomial that comes from the coefficients on the bottom of our synthetic division. Look at the synthetic division we did. On the bottom, we have the number 1, the number 1, the number negative 2, and then, of course, the 0. So if we use those as coefficients of a polynomial 1 degree lower than the original p of x, that's what we're going to multiply the x minus c by. All right, so our original polynomial was 3rd degree, so we're going to use these coefficients to write a 2nd degree polynomial. See, we're going down 1 degree. So that's 1 times x squared plus 1 times x minus 2. That will be the product we're going to multiply. The other polynomial we're going to multiply by. All right, so let's clean this up. The double negative p of x is equal to x plus 3 times x. Well, we'll factor by guessing. X plus 2 times x minus 1. So this is the complete factorization of this particular polynomial. And we were able to do this by carefully using information on the bottom row of our synthetic division after we got our 0 remainder. Now, they asked us to find all the roots. They gave us a possible root c equals negative 3. We tested it. We got a 0 remainder. We had a party. We stated c equals negative 3 is a root. So in our list of all the roots, if you look at the factorization at the bottom here, we have x minus the root. So it's x minus a negative 3. So negative 3 is our first root. Times, let's see, then we have x minus a negative 2 to get the x plus 2. So negative 2, the number we're subtracting, is our second root. And clearly 1 is the number we're subtracting in the last factor. So the list of all of the factors for this polynomial are negative 3, negative 2, and 1. Point is, if you get these things factored all the way down to 1st degree factors, the number being subtracted from x in the parentheses, those will always be the factors, the roots of your polynomial.